Hey 8th graders, today we're going to be talking about solving equations with variables on both sides. So our essential question is, how can you solve one of these equations with variables on both sides? And again, when we say both sides, we're meaning both sides of the equal sign will see variables. And these are just one variable equation, so it'll just be the same variable on both sides. And how do we do this? Well, we're going to collect the variable terms on one side and the constant terms on the other. Now remember, constant terms, those are just our plain old numbers, so no variables. So let's try this out. Solve 15 minus 2x equals negative 7x and check your solution. So let's just start out by making a nice t-chart. And let's see, the next thing I'm going to do is I'm just going to kind of look at my terms and classify which ones are constants and which ones have variables. So 15, that's a constant, and this minus 2x, that's a variable. Remember, I'm keeping that minus sign with the 2x. If I wanted to, I could also rewrite that as a plus a negative 2x. But the minus is going to stay with the 2x. And moving on to the other side of the equal sign, well, that's a minus 7x. Well, now I can decide which side do I want my variables on and which side do I want my constants on. Well, my right side only has variables, so it kind of makes sense to move all the variables to the right side. And my left side is the only side with a constant, so I'm going to move my, well, there's no constants to move, but I'm going to keep my constants on the left side. Now, let's see, I want to move, so let's see, on my left side there's a constant and a variable, but I just want constants. So I want to move that variable to the right side. So that variable minus 2x, well, how am I going to get rid of it? This is now just like when we were doing our one-step and two-step equations. I get rid of that minus 2x by adding 2x, right? That's my inverse operation. So I'm going to add 2x to the left and add 2x to the right. Well, on the left, 15 minus 2x plus 2x, the 2x's cancel out. I'm just left with 15. And on the right side, a minus 7x plus 2x, well, that's minus 5x. Now look at this. I just have a one-step equation left. So now I want to get rid of that minus 5, right? Because that is in the way of x being by itself. Now, how do I get rid of the minus 5? Well, it's minus 5 times x. So how do I get rid of that? I'm going to divide by minus 5, or negative 5. So when I divide by negative 5, on the left, 15 divided by negative 5 is 3. And on the right, negative 5x divided by negative 5 is just x. So my answer is x equals negative 3. Now again, I have to check my solution. So I'm going to plug negative 3 in wherever I see an x in my equation. So 15 minus 2x, so I'm going to put in negative 3, is supposed to be equal to negative 7x. Well, x is negative 3. I'm going to put that in. Well, let's simplify the expression on the right. Well, order of operations tells me I'm going to multiply first. So I am left with 15, well, minus 2 times negative 3, that's going to be a plus 6. And 15 plus 6 is 21. Now on my right side, negative 7 times negative 3, oh, that's 21. These two are equal, so I was correct. Oh, I'm struggling to scroll, guys. Okay, I got it now. So next one, solve 3 minus 4x equals negative 7 minus 4x. So I'm going to make my t-chart. And let's see, I'm going to find my variables and constants. So I have a constant right here. Let's see, minus 4x is a variable, minus 7 is a constant, and minus 4x is a variable. Now there's constants and variables on both sides. So I can pick. So let's see, I think on my left, I'm going to do variables this time. On my right, I'm going to do constants. And again, I could pick. I could have done it the other way too. It's just my choice. So let's see, I want all my variables to be on the left. So let's work on getting that minus 4x to the left side of the equation, right? So this minus 4x right here to the left side. Well, how do I get rid of that minus 4x? Well, I'm going to add 4x, right? That's going to get rid of that minus 4x on the right side. Whatever I do to the right, I'm also going to do to the left. So I'm going to add 4x to the left. And let's see, on the left, 3 minus 4x plus 4x, it cancels out. I'm left with 3. And on the right, minus 7 minus 4x plus 4x cancels out. So I'm just left with that negative 7. And I have 3 equals negative 7. Well, let's see. That's a false statement. 3 can never be equal to negative 7, right? That does not work. That means that this equation has no solutions. So if this happens when you're working, your answer is no solutions. That means I could never find an x that would make this equation true. And if you tried a bunch of different values for x, you would see that none of them work. Any value for x you could ever possibly imagine or pick would never make this equation true. Time for another example. 6x plus 4 equals 4 times 3/2 x plus 1. Well, first of all, it looks like there's something I need to simplify. See my parentheses, meaning it's time to do the distributive property. So on the right, I'm going to distribute the 4 to 3/2 x and 4 to 1. So 4 times 3/2 x, well, 4 times 3/2 is 12/2. Well, wait, 12/2 is just 6, right? Because that's 12 divided by 2. So I'm left with 6x. And then 4 times 1 is 4. So on my right, I have 6x plus 4. On my left, I'm just going to re-drop down what was already there, 6x plus 4. And then I'm going to make my t-chart. Well, let's see. Let's go through and classify 6x. That's a variable. 4 is a constant. 6x. Oh, whoops. I meant to change that to red. 6x is a variable. 4 is a constant. And again, I can pick. So which side should I put variables on and which side should I put constants on? Let's do variables on the left and constants on the right. Okay. So let's move this 6x right here over to the left. That will be our first step, okay? Move that on over. So this is a positive 6x, right? So how do I get rid of a positive 6x? I'm going to subtract 6x. I'm going to do that to the left side as well. Well, when I subtract 6x on the left side, well, 6x minus 6x, those cancel out. I'm just left with that constant 4. And on my right side, well, 6x minus 6x, those cancel out. I'm just left with 4. So now I have 4 equals 4. Well, that's a true statement, right? That means that there is infinitely many solutions. That is the answer that I would write down, infinitely many solutions. That means whatever I pick for x, any single x would work. There are infinite possible values for x because every x would work. And you could test this out. For example, what if I just picked a random x, let's say 0? And I like to pick 0 because it's easy to plug in. So if I plugged in 0 for x, I would see that the equation is true. So 6 times x, or 0, plus 4 equals 4 times 3/2, well, x is 0, plus 1. Well, that's simplified on the left. 6 times 0 is 0 plus 4. I'm left with 4. On my right, I have 4 times, well, 3/2 times 0 is 0 plus 1, which is 4 times 1, which is just 4. Well, 4 equals 4. That is a true statement. So 0 is one possible answer. But if I tried this with 1 or 2 or negative 7, 130, pi, 12.5, all of these would work. Any value for x would work. Okay, 8th graders, we're just going to finish off with a fun word problem, okay? So a boat travels X miles per hour upstream on the Mississippi River. On the return trip, the boat travels 2 miles per hour faster. How far does a boat travel upstream? Well, let's see, what is my question? That's how far does a boat travel upstream? Now, what are my important information? Well, let's see. The boat is traveling X miles per hour upstream and 2 miles per hour faster, and that's on the return trip. Those are connected. And let's see, what else do I know? Well, on the way upstream, if we look at our picture, it looks like it took them 3 hours. On the way downstream, it only took 2.5 hours. Well, that makes sense. They traveled faster on the way down, right? Well, let's see. What do I know that can help me write an equation? Well, I know that this, let's see, let's pull up our highlighter. This distance right here that they're traveling is the same, right? They just traveled upstream and then they traveled right back. This is the same distance. So the distance upstream equals distance downstream. Now, well, what is their distance upstream? Well, I don't know if you've learned this in science yet, but we know that our boat traveled for 3 hours upstream at X miles per hour, right? So if you travel 3 hours for X miles per hour, or the amount of time times the miles per hour is going to give you distance. So that's something that you might have learned in science yet, but it makes sense. If you're traveling at 60 miles per hour for 1 hour, you traveled 60 miles. If you traveled 60 miles per hour for 2 hours, do 60 times 2, that's 120 miles. So your miles per hour times your time is going to give you your distance. So my distance upstream is going to be, well, we traveled 3 hours at X miles per hour. So that's 3 times X is going to give us our distance upstream. And that's supposed to equal our distance downstream. So we traveled 2.5 hours for, well, what was my mileage or my miles per hour downstream? Well, that was, let's see, we traveled 2 miles per hour faster than upstream. Well, we traveled X miles upstream, and now we're traveling 2 miles faster. So we're traveling X plus 2 miles per hour downstream. So again, 2.5 hours times our miles per hour of X plus 2. Okay, now I have an equation. It's time to solve. It looks like I have to deal with the distributive property first, okay? So let's distribute that 2.5x in. So 2.5 times x is 2.5x. 2.5 times 2 is 5. And I still have that 3x on the left. So now I have an equation. Let's see, let's look at our constant. So I have a constant here, or a variable here, and a constant here. It makes sense that I would want to keep my variables on the left because there's only variables there right now. My constants on the right. Let's make a t-chart and let's see. I want to move my variable, that 2.5x, over to the left side, right? I want to get rid of it and move it to the other side. So how I'm going to get rid of it is, well, this is a positive 2.5x. So I'm going to subtract 2.5x from the right and subtract it from the left. So 3x minus 2.5x is 0.5x. And 2.5x plus 5 minus 2.5x, those cancel out. I'm just left with 5. Now let's see. I have 0.5x, and I want to get x by itself, right? So that 0.5 is in the way of x being by itself. How do I get rid of that 0.5? Well, I'm going to divide by 0.5 on both sides. Now again, you could use your calculator for this, or you could use long division, because long division is so fun. So 0.5 divided by 0.5, well, we're just left with x, those cancel out. And 5 divided by 0.5, well, that's going to be 10. So x equals 10. Now let's go back. Let's see, did we answer our question yet? How far does a boat travel upstream? Well, we know x is 10. X is our miles per hour, right? So we don't know the distance, but we know our distance, up here, we talked about our distance upstream as 3x, and x equals 10. So my distance upstream equals 3x, which is going to equal 3, because 3 hours, times 10 miles per hour is going to give us 30 miles, right? And that makes sense, right? So if I travel for 3 hours, going 10 miles each hour, well, I went 10 miles my first hour, 10 miles my second hour, 10 miles my third hour. That's a total of 30 miles. So now let's just put this into a final statement. The boat traveled 30 miles upstream. Thank you for watching this video. Make sure to do your on your own problems that are left on your notes. Bye.